All right.
Just 15,
So
which is
15.
orthogonal, and then 18 that find that.
So 15 and 18. Determine if they're orthogonal. What's orthogonal mean? Perpendicular. And what do we know about orthogonal vectors? Their dot product is 0. Whoops, if we forgot that, we gotta remember it. The dot product of orthogonal vectors is 0. Think about it for a minute. If you have a vector whose slope is, let's just say, 2 over 1 up 2, then wouldn't a perpendicular vector, an orthogonal vector, be 2, -1? Wouldn't that slope be -1/2? And what happens when you find the dot product of those two vectors? First times first, second times second, you get 0, don't you? So if I want to know if these guys are orthogonal, I am simply going to dot them. And if I get 0, it's a yes. If I don't get 0, it's a no. Well, how do you think we're going to dot three-dimensional vectors, Madeline?
You do the x and then the y and then the z.
Absolutely, yep. So x's give me 6, y's give me -12, and z's give me 3. Does that add up to 0? No. So they are not orthogonal. What is that, -3? So no, they're not orthogonal. And then 18 says, okay, we know the angle between them isn't 90 because they're not orthogonal. So what is the angle between them? Well, how do you find the angle between two vectors? This is important. Drew?
Magnitude times magnitude times angle between those dot products.
So we're going to use this number right here. This is the dot product. And the dot product equals the magnitude of the first vector. Oh my gosh, how do you think we find the magnitude of a three-dimensional vector? How do we do a two-dimensional vector? Square the first one, square the second one, add them up and square root it. How do you think we do it in 3 dimensions? Square the first one, square the second one, square the third one, add them up and take the square root. So that's going to be the square root of 1 plus 4 plus 9, which is 14. And this one's going to be 36 plus 36 plus 1, 73, times the cosine of the angle between them. The dot product equals magnitude times cosine. So we'll definitely need a calculator for that. So second cosine, -3 divided by the square root of 14 times 73. You get 95.38. As the angle between. Can they match that? Somebody match that? Okay, good. All right, good question. But what's the moral of the story? It's exactly the same. There's just more of it to deal with, but everything's exactly the same. All right, so what else did someone find? Meredith.
14.
Okay, now, we did this yesterday. We'll do it again. To find the airplane flying in the sky, and we have the wind blowing at it, and we want to find the actual speed and direction. What do we have to do? What is our big picture strategy? Well, we have to find the coordinates of each vector, right? We have to resolve it into its horizontal and vertical component. So we want to do the plane, we want to find his x and y, and then we want to find his x and y, and resultant, x and y, right? So here we go. The airplane is traveling 331 miles an hour on a course of 190 degrees. So remember, a course of 190 is going to look like this, right? That's a course of 190. So what is the angle that we're going to use in the problem? The speed was 331. What angle are we going to use? X is going to be 331 cosine something. Y is going to be 331 sine something.
260.
I need the angle in standard position, which will be this one. So you need to figure out what that is. I heard somebody say 260. That makes really good sense because isn't this little thing 10 right here? So we're going all the way around almost to 270. So 260 sounds great. And then the wind is south 17 degrees east. So go south and then veer 17 degrees east. He's 28 miles an hour. So the wind is going to be 28 cosine and 28 sine something. And the angle I need is not 17, the angle I need is this one, which will be 270 plus 17, so 287. And now to get the actual coordinates of the coordinates of the actual vector, I'm going to add my x's, so 331 cosine 260. Plus 28 cosine 287. And I'll add my y's. Hopefully I did that right. Does that match up? Now, those are the coordinates of the vector. So if I drew the vector, he would look like this. Left 49.29 and down 352.75. This is the speed. Just like when the wind was blowing, the magnitude is the speed. So I'll do the Pythagorean theorem to find that. That is 356. Miles an hour. And then to get his actual direction, now remember, I want a direction now. So I need that. So let's see, I guess I'll find that first using second tangent. I got 82.05, so this guy right here is 82.05. So how could I get my red directional angle there?
You can do 90 plus 82.05 plus 360 minus that.
You could, or I could just use 270 minus that. Same thing. Now you use 90 and 360, same thing. However you did it, your direction should be 187.95 degrees. Okay? All right, who else found something that we need to look at? Robert?
Yes, 8E.
Which one?
8E.
8E. 8E. talks about vector AB, so the first thing I better do is find the coordinates of vector AB. So what are the coordinates of vector AB? 6, 11. Those are the coordinates of vector AB. What is the magnitude of vector AB? Square root of 36 plus 121, which is the square root of 157. Now, every vector has a corresponding unit vector in the same direction. So again, this vector 6, 11 looks like this. Oh, well, my proportion's not good, but this is what it looks like. I can make this a unit vector, in other words, have a length of 1, by just dividing everything by the square root of 157. Now the length of it would be 1, right? But the problem didn't say find a unit vector. It said find a vector with a length of root 7. Well, that's easy. If I want this unit vector, which has a length of 1, to have a length of root 7, won't I just multiply everything by root 7? So the coordinates of the vector would be 6 root 7 over 157, square root 157, and 11 root 7 over the square root of 157. You can make a vector have any length you want it to have by first of all changing it into a unit vector and then multiplying it by whatever length you want it. Okay? If you square this and add them up and take the square root, you're going to get root 7. All right, who else found something on there? Emma?
Can you do 7D?
7D. 7D just says find the magnitude of this number. Well, Emma, I want you to think about that number for a minute. If I told you to graph that number, you know that's R and that's theta, right? If I said, okay, graph this, now it's polar, we got a polar paper. Okay, 295 would be down here somewhere, right? And a length of 6. Okay, there it is. There's the number. What's its length? What's the length of that vector right there? That's 6. Magnitude 6. R is the magnitude. R is the length of the vector. When we say absolute value, we mean distance from the pole, and obviously that's 6 units from the pole. What?
Could the magnitude be like negative though?
No, not in polar form.
Okay.
Not in polar form. In polar form, R must be positive. R must be positive. Sam?
Can I ask a question about the homework?
Let's finish the review sheet and then we'll get to that, okay? Let's finish up the review sheet. Is there anything else on the review sheet we looked at? Yeah, Jennifer? 13. What's work, Jennifer? How do we find work?
Finding
Force times distance times cosine of angle between. It's an application of the dot product. Okay, you need to know that in order to do the problem. So what's my force? 111. What's my distance? 16. And the unknown is the angle. I don't know what the angle is. So let's look at our situation. We have our force acting in the direction over 5 up 2. So that's over 5 up 2. Those are the coordinates of that vector. And then we're moving it along the line y equals 3x. Now, when we say y equals 3x, that means up 3 over 1, right? So this is actually the vector 1 comma 3. I need this angle right here. Well, we've already done that today, one way anyway. How did we find the angle between two vectors earlier, Sam?
We found the dot product and then set it equal to the magnitude
Yep.
times the.
So the dot product of these two would be what, 11? And that's gonna equal the magnitude of this vector, which is root 10, times the magnitude of this one, which is root 29, times the cosine of the angle between them. So the cosine is 11 over root 290. And that is the number I need right here. So one option I have is just to type that in, and that's gonna be the answer. Now, since you've got a calculator on this problem, so actually everything I did there I could do without a calculator. I could finish the problem, leave it in radical form, and not use a calculator. But if I have a calculator, can I find this angle right here by doing second tangent 2/5? And then I could also find this angle by doing second tangent 3, and then subtract those two angles to get the one I wanted, and then take the cosine of it and plug it into my formula. So both of those are options. So whatever way works, makes most sense to you, is easiest for you, that's what you'll do, since you've got a calculator on that problem. Okay? David?
Can we do 17?
17. 2,800-pound car. Here's the horizontal, here's the 14 degrees, here's the car, and he weighs 2,800 pounds. So his vertical pull, gravity pull, is 2,800 pounds. Find the force needed to keep the car from rolling down the hill. All right, so I'm gonna make a right triangle here. And this is the question right there. Because if the car is gonna roll down the hill, that's where it's rolling, right? So pretend you're like a big, strong guy. You're gonna be standing right here, holding on to that car. That's the force that you're gonna have to exert to keep it from rolling down the hill. All right, I'd like you to think about this for a second. That's a vertical. So if I look at this big right triangle, if that's 14, what's that guy right there? 76. That's a right triangle. Can I find x? Sure I can. What? Cosine 76 equals x over 2,800. So 2,800 cosine 76 is the answer to the problem. 677.38. Okay, David? All right. Robert?
Why is 6E not hyperbolic?
Y is 6C. 6D. E. A hyperbolic spiral divided by theta. Sixty is theta over 2. Right? Yeah. Hyperbolic spiral is theta in the denominator. And it's not in that problem, so. Alright, anything else on the sheet? Next.
Number 5.
Alright, we did one like this yesterday, but maybe it was the other class, I can't remember. How do I approach problem number 5? If I have to change it into a polar equation in graphable form. What am I gonna do? Then?
You just take the square root of the x squared y plus 3
Oh, okay, all right. Now I'm starting to twitch. Stop and think about that for a minute. And would you agree that 3 squared plus 4 squared is 5 squared? Is that a true statement? Yeah, right? If I take the square root of each piece, is that a true statement? Oh, you cannot, you are allowed to square root both sides of an equation. You are not allowed to square root pieces of an equation. You would have to do the whole side. So no, don't think I'm going to do that. What might I do? What's another thought? What's another thought? David?
FOIL the y plus 3, still get the x squared plus y squared equals 1.
Yeah. That's what I like to do. I like to FOIL it, because I'm going to do some substitution here in a minute. I'm going to take out the x's and substitute in our cosine, take out the y's, substitute in our sine. I can do that right at the beginning, but then I have to FOIL with those things, and it's easier for me to FOIL with the x's and y's. Plus, as David said, what do I know about x squared plus y squared? It's r squared. And y is our sine. And the 9's are going to cancel. Now this is a lovely polar equation, but it's not in graphable form. When you put a polar equation into your calculator, how does it have to look? How does the equation have to look? R equals. So we got to change this somehow so it's R equals. Madeline?
You start with factoring out R.
Actually, I'm going to do better than that. I'm going to divide it out. I am allowed to do that because R isn't 0. So I'm allowed to divide it out. Factoring is division, so it's the same thing, but it's just gone, Madeline. It's disappeared. And then just move this over. Now, the original problem is the equation of a circle centered at 0, -3 with a radius of 3. If you graph this equation in polar coordinates and on your polar system, you better get that very same circle. You better get a circle that's moved down 3 units with a radius of 3.
I have a question for that. So if you would have not divided the squares, would it be wrong if you had subtracted the 6r or the 6? Oh, never mind. I see where the R was.
Yeah, you have to have R equals. Whatever you do, the answer has to be R equals if it's going to be in graphable form. All right? Who else? Ava's your hand up?
No.
You have no questions, Ava? Did you try 3A, Ava?
Yes.
Okay. We want to find polar coordinates. So what was the first thing you did, Ava?
I drew.
Yep. Drew a picture. So over 3x up 2, okay.
And then do you have to find the I don't really know
Okay, well, do you know what polar coordinates are?
when I look at my notes.
Okay, we need to know that without looking at our notes. Polar coordinates are r comma theta. Those are polar coordinates, r comma theta. So yes, you need the hypotenuse, Ava, because that is r. So root 13. And then I need a calculator for this problem because I need this angle right here, that's my theta. But this isn't a special triangle, so I'm gonna need a calculator to do it. And I'm to do it in radians according to the directions. So I'm gonna switch to radian mode. And I'm going to second tangent 2/3. And then subtract that from pi. So I got 2.55. So second tangent 2/3, Ava, second tangent 2/3, and subtract that from pi, since I'm radians. Okay, done with the review sheet. All good. Okay, then let's get Sam's homework question.
Definitions for
Hmm?
you.
All right, so Sam, what was your homework question?
Number 5 on the back.
On which assignment?
6-6.
6-6, number 5. Okay, we did run these last time, we'll do it again. Here we go. We're solving for A. Okay, so in order, we want to get A equals. So we got to get rid of that exponent. So we're going to raise both sides to the 3/2 power. That'll clear that exponent out. So I'm really raising this guy to the 3/2 power. So in other words, I'm cubing it and square rooting it. I can do that in 2 separate steps if I want. I can do de Moivre's theorem and cube it, and then I can do de Moivre again and square root it. But it's easier just to do it all in one step, since de Moivre will work with every single exponent. So, what do I need to do if I'm going to use de Moivre's theorem on this? That's how I raise complex numbers to powers. I use de Moivre, but what do I have to do first? I gotta get it in polar form. So -2√3 and 2. This is exactly what we just did with Ava. That's gonna be 4. This angle is 30, so that's gonna be 150. And that's the number I'm raising to the 3/2 power. This problem is doable without a calculator. I don't need a calculator to do this problem.
Wouldn't it be 120? Or if wouldn't that angle instead of trying to do 30?
It is 30.
34. Oh, okay. Sorry.
Right?
Yeah.
Okay. So, now I'm gonna actually do the theorem. So I'm gonna take 4 to the 3/2, and I'm gonna multiply 150 times 3/2. 225, 75 times 3. So there's my first answer. Now, how many answers should I have? 2. Remember, rooting gives you multiple answers, and the number of answers you have is whatever root you're taking. So the 3 isn't involved in that. I mean, obviously it's involved in the answer, but the number of answers is right there. That's 2. So since there's only 2 of them, they will be how far apart? 180. So the second one is going to be 180 away from that one. Well, I think this is another case where I'd rather subtract 180. I could add 180, but what happens if I add 180? I'm bigger than 360, so I just gotta subtract 360, and either way, it's gonna come out to be 45. All right, let's clean this up a little bit. What's 4 to the 3 halves? You can do this without a calculator. That means the square root of 4 cubed. So that's 8. So it's 8 CIS 225 and 8 CIS 45. Those are the polar forms of the 2 answers. But the directions say answer in complex form. So that means x plus yi. So x is 8 cosine 225, and y is 8 sine 225 for the first number, and then 8 cosine 45, oops, and 8 sine 45 for the second number. So again, we can do this totally without a calculator, because what do we know about 225? It's a special one. So what's the cosine and the sine of 225? Negative root 2 over 2. So we're going to take 8 times negative root 2 over 2. And that's going to give us negative 4 root 2 minus 4 root 2i. So there is the first one. I think we did this problem yesterday, because the second one, since there's only 2 of them, they're 180 degrees apart, we're just thrown right across the circle, right across the origin. So isn't the cosine and sine here just going to be positive root 2 over 2? So that one's going to be 4 root 2 plus 4 root 2i. And there are your answers in complex form. Madeline?
We do 40.
Are we done with this one? I have to erase it all.
Why did you count from 8 to 4? Did I do my power wrong?
When you're multiplying it by the cosine. So it's 8 root 2 over 2.
Oh. Do we have to rationalize that?
Probably that one, because we've used that number over and over again.
Alright.
Okay, which one did you say, Madeline?
4B.
4B says find the cube roots. This one I may need a calculator. It's the same problem, basically. Only cube roots mean what power?
1/3.
1/3. What do I need to do first, Madeline?
Polar.
Yep. Drawing a picture there. 1648.8. So this is 150 also, it looks like. So it's going to be 8 CIS 150. And that's what I'm taking to the 1/3 power. All right, so what does Demois tell me to do when I take a number to the 1/3 power, I'm going to 8 to the 1/3, CIS 1/3 times 150. There's my first number. By the way, what's 8 to the 1/3? That's the cube root of 8. So my first number is 2 CIS 50. There are going to be 2 more of them though, because there's a total of 3. And since there are 3 of them, they will be how far apart? 120. So the next one's going to be 170 and 290, right? Now those are the polar forms. So where it says P, that's it. Those are the polar forms. Now the complex forms, I am going to need my calculator. I am going to need to change into degrees, unless I change those to radians and that would be a hassle. So here we go. 2 cosine 50, 2 sine 50. So the first one is 1.29 plus 1.53i. 2 cosine 170, 2 sine 170. The next one is negative 1.97 plus 0.35i. And the last one, 0.68 minus 1.88i. Okay? All right, anything else from the homework? Or from whatever, Tyler?
6.5,
You did it yesterday. Oh, yeah, it's on the video. Yeah, just watch it, it's on the video. David?
I'm on number 4, A of 6, for the complex solution. I'm confused on how the y portion is positive.
Okay. I don't know if I can work it out. Negative root 3 minus I to the 4th power. Okay, so I need to change it into polar form. So 2 CIS, this would be 210. Is that right?
It's 2 plus 40. Oh wait, no, I did it wrong.
So then when I do DeMauve, I get 16 CIS 840, which is way too big of an angle, so that's gonna be 16 CIS 120. And that's my polar form, but where's 120 degrees, David? Quadrant 2? So that's why y is positive, because the answer is in quadrant 2. I did post the answers, I just did it this morning, but I posted all the homework answers. Particularly those of you that submit stuff electronically, you might want to take a look at that since your papers don't actually get graded. Okay? All right, well, we're gonna get started on our chapter 7 notes. Only gonna do the first couple because it's so easy. It's stuff you've done before, it's nothing new. We'll get this out of the way so we can start the new stuff. Remember, your test on Monday is over the entire entire chapter. So that's all the notes, all the homework, all the reviews. Make sure you spend some time. All right, chapter 7 is all about solving systems of equations and inequalities and different applications of that. So, you've already done this. You did this probably when you were in 7th grade. How do you solve a system of equations? Let's call a system of equations. How do we solve a system of equations? Okay, so we can substitute, we can eliminate, right? Those are the two things you know so far. We're going to learn a bunch more in this chapter, but right now you already know how to substitute and eliminate. So this particular problem says solve using substitution. What does that mean? Well, Ben just told us. He said isolate a variable. Get a variable by itself. Doesn't matter which one you get by itself, but please get it by itself carefully. I would probably get this guy by himself. That I don't like dealing with fractions, and so if I do that, I won't have to deal with fractions, but I do have to be careful there's a negative in front of it. So if I move it over here, and move the 10 over here, would you agree that y is 2x minus 10? So then I take, it's called substitution, because now you take the y value and substitute it in. So 3x plus 2 times 2x minus 10 equals 1. You guys know how to do this, right? I mean, this is easy. Okay, so now we do the arithmetic. We get 7x equals 21. Oh, isn't that lovely? So x equals 3. This is what happens when we rig them. If we just make them up, this doesn't happen. But it's rigged. So here we go. We got 3. Then what? Plug it back in anywhere you want. I like to plug it in right there, but you can plug it in anywhere you want. And if you plug it in, it looks like my y value is going to be -4. So I write my answer like this, because what you just did is find where this line and this line cross each other. When you solve a system, you're looking for their intersection. They intersect at the point 3 and 4. All right, that seems easy. All right, let's look at an application now. We're still using substitution. It says find the dimensions of a rectangular garden whose perimeter is 100 and whose area is 300. Okay, so think about your rectangle. Now please don't call them all x. You can't call them all x because why? We don't know that it's a square. It might end up that way, but we don't know that it is. So maybe we call this x and this y. Now we're going to build a couple of the equations from that. If the perimeter is 100, then I'm just going to say x plus y equals 50. Is that okay with everybody if I just do that? And then the area is 300, so x times y equals 300. Now it says use substitution. So, I don't know. Does x equal 50 minus y? So I'll plug that in here. So now I have, what, 50 minus y times y equals 300. Does that look okay to everybody? All right, so I'll distribute. So 50y minus y squared equals 300. Oh, what kind of equation do I have? I have a quadratic. So I gotta get it equal to 0 and then figure out what I'm going to do with it. So, you know me and my issues, I gotta move everything over here so my y squared's positive. Alright, so what am I gonna do with that guy? If I can see how it factors, I don't know that it factors, but if you can see how it factors, you can go ahead and factor it. If you don't see how it factors and don't wanna mess around with it, you can use the quadratic formula. Anybody see that factoring? Alright, let's use the formula then. Y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, it doesn't factor. So we have 50 plus or minus the square root of 1300 over 2. If I did my arithmetic right, I used a calculator, so I hope I did. Alright, so 50 plus the square root of 1300 divided by 2. So one y value is 43.03. And 50 minus the square root of 1300 divided by 2, 6.97. Now I want you to look at something. I erased my picture. But if y is 43.03, what will x be? 6.97. And if y is 6.97, then x will be 43.03. So the question said, what are the dimensions? The dimensions are 4303 by 6.97. Doesn't matter which one you call length and width. Those are the dimensions. All right, one more, then I'll stop and we'll be done. We're gonna do letter C. This is a big, scary looking system. It is not 2 lines. It is a cubic function and a line. And we want to figure out where they cross using substitution. Yeah, this is easy. They're both set equal to y, so we'll just set them equal to each other. Now it's not quadratic, but I still want to get it set equal to 0, right? Quadratic formula is not an option. It's not a quadratic, so what am I going to do with it? Factor out an x. Oh my golly, what happens when I factor out an x? Got the difference of squares. So we're actually going to have 3 points of intersection. We're going to have a point of intersection where x is 0, where x is 3, and where x is -3. All right, if x is 0, it looks like so is y. If x is 3, y is 9. And if x is -3, y is -1. I told you it was easy stuff. Easy stuff. In the beginning, it's always easy. Alright, that's it. Next time I see you, we have a test. Let me know in the next week or so if you and your parents want me to pursue BC calculus, and we will talk about it. Yes, I understand. You're gonna see the work.
Yeah.
You're not gonna take an A.
Like,